Hi everyone. So today we'll start implementing the support vector machine in RStudio. Please don't come to this lecture until you back to the theoretical part that we've discussed in the previous lecture. So we start by uploading our CSV file. It's the same CSV file we used before. I'm gonna call my CSV file. This is movie CSV file. Classification I'm called movie. This is I've used the read.csv file to upload my CSV. First we have to check. So and we check our data. So in the summary you have to use the summary to check your data first. I can check the NA value in here. That means I have missing value in here. So I need to remove all this missing value first before we start working on. So to remove your missing value you have to use this function. So the data in the movie and we have the missing value in time taken equal dot. Do you have this function is dot NA? This function allow you to indicate all the missing value within the movie start taken, and then we use the mean function to remove first all the to remove all the missing value assigned to true. You have to run this one, and then if we use check our column, so this is to check your predictors. You can say just miss equal to, this is called .sums function is .na .movie. We have the data equal movie. We can check now if we have any missing value and we print that. So you can check now all my independent variables is 0 0, even the time taken 0. That means instead of 11 we have 0. Now you can start working on your data. Okay, so before we now we have to split our data. So check for CA tools. You have to unback. This is CA tools. Okay, you should unback, and then we have to set our seed, and we have to set our seed. So we have 80% fixed 80% and 20% for test and 80% for train. If you don't set your seed, you will have different value every time you run your model. So this is so mandatory to set your seed first. So today we'll focus on a classification. If we check our movie data in here, so this is the data that we are working on. We're gonna focus on start tech Oscar. The RStudio stored this one as a numeric with range 0 to 1. So first we have to convert it to categorical. We have to change it to categorical. So train data start tech Oscar, we needed to convert it as dot factor. This is train start tech Oscar. And also we do the same for the test data, because we split our data into train and test. The purpose, we have to change our from a numerical to categorical data. If we go for train now, we go for start tech Oscar, you will see it's vector with 2 levels. We need to change it in 2 levels, 0 or 1. So now it's vector. We can use that classification. So for today we will start with fitting our models. We use the support vector machine with kernel. If you don't know what I'm talking about, just back to the theoretical part. We discussed today support vector machines with kernel. It's gonna run. You have to unback first the E. So E1071, you have to unback this one first to use it for the support vector machine. So I was gonna first set our C to 0, and now I was gonna support vector machine. So this is a question mark. Support vector machines allow you to open the help, and we can use the help to explain in more details. So we use the support vector machine function. This is start tech Oscar, our dependent variables that we need to predict, and this is the tilde and dot. This is for all our independent variables. Data equal to train, and use the trained data to fit my model on. And this is kernel equal to linear. So if you check the kernel, we discussed in the theoretical part, but it's okay. So we have 3 or 4 type of kernels, and today we'll use the linear one. And we have polynomial, we have radial bias, we have sigmoid. So we use the linear purpose in here, and we change to the polynomial radial one, one by after one. So I'm gonna use the cost equal to 10. And if you don't know what is the cost, we're talking about in the theoretical part is the C, and is the C function that we said it is the same, because this is like a support vector machine is the same as a support vector classifier, and we talk about the B is equal to the total loss, and we use the cost is the same as we, because we said we allow misclassification in this method. We allow for some for misclassification, and we control it by C. So the cost is to control the misclassification, how much error we allow, how much misclassification we allow in our model. So we have to find the best C that fit our model. And the scale equal to true. This one is when you have we have 19 variables, so some of them in thousands, some of them in decimal, some of them is maybe currency. So we have to scale our model to be from 0 to 1, 0 variance and 1 standard deviation. So the model will be easy for model to fit. Okay, I was gonna run our model. Okay, and I was gonna check the summary. So the summary of our model, we use the C classification, we use the linear as a SVM kernel, support vector machine kernel is linear. The cost, we use the C value is 10. So if you have high value of C, that means we have low value of number of supporters, only 283 from 399. Okay, so let's gonna check the support. Now we will just use the predict function on the test data to check our model on the test data and scene data. So CVM predict equal to predict data, and then we use the table as this is CVM predict, the predicted value, and this is the test start equals car, this is our real value, and we check our model. So we have 28 with 33. This is like this is the corrected value, this is the accuracy. And if we check now this one, if to check the support vector, if you need to check all your support vector, so this is CVM fit, our model support vector machine fit, $ index. This will allow you to check all your support vectors. We have 39.8 from 39.9 observation, so all these is work as support vectors. But in this method we need to find the best C value, the best tuning parameter that give us the higher accuracy. So in this one, in the previous one, we get 28 plus 33, so this is like this is 61. Okay, but we need to, this is like 61. So let's gonna check what's the best C function to fit our model. And to find your best C function, we have to use the first, we set our seed function. We use the tuning parameter, tune.out, this is just a naming that I'm gonna resolve the data in here. We use the tune function, CVM function, this is my independent variables, this is tell all my data equal to train, and the kernel is the same as linear kernel, and we use the range. Range is equal to the list, and the list is cost equal to C function. So we put from 0.1 into the 100, from lower value to 100 value, and we need to find which the best C value that give us the best accuracy. So if we run that, we use the tuning parameter, so it's going to take some time. I'm gonna wait. Okay, and now we find, I just name it the best model equal to tune.r, tune.out. This is the fitting model, and this is the dollar sign is with best model. So if you just write the dollar sign, you will have the best.model is already reserved in the tune.out. If we click on that and we give him the summary of the best model, the best mod, we can check. So it is a cost function equal to 1. This is the best C. Let's gonna check. We use the 1 and how much will give us. So if we use the C equal to 1, it gives us C equal to 1 as the best model. So we will use the best model, best mode, this one, with the test data, and we check the best model on the predicted with the test data, and I'm gonna name it as a pred tune. Run that, and then I'm gonna just use the table. This is the pred tune. Okay, and this is my predicted value, and this is my test start the cost car. This is the actual value. We can see we have 30 and 36, so this is like 66. The previous one we got 61. The previous one with the C equal to 10 we got 61, but in here we got with the best tuning parameter we got like 66 value. So this is how we use the tuning parameter to find the best C to fit our model. And then we'll use the kernel equal to polynomial. This is for polynomial kernel. We discussed in more details in the previous theoretical part. So if we run that, it's the same function, but all you have the same. This is SVM, support vector machine. This is same our classification, independent variables, data to train. We fit our data on the train, and kernel in here equal to polynomial, and the cost equal to 1. But in the polynomial we add the another functions and call this d. So we use the degree. I was gonna check the CVM. Also we have them here. So we have the degree in here. This is parameter needed for kernel of type polynomial. So we said it will this degree of the d in the previous video we said it will use in the polynomial is for fitting our model. So the value of d is so important here. And also we need to find the tuning parameter for d, which is the best value of d that will fit our model. So hyperparameter tuning, tune.out is the same. Tune function, support vector machine is our independent variable, independent data equal to train. We use the cross validation equal to 4, so no need to equal to 10 if it will take a long time to run. Cross validation equal to 4, and kernel equal to polynomial. And here we go. Here we use the range. Also we need to find the C value for the polynomial, and also we need to find the best degree, the C, the best degree value that will give us the best accuracy for our polynomial model. So we run that. Okay, so first you have to set your seed first. Will not change that, and run our model. I'm gonna run the tuning parameter. Okay, it will take time. That's why if you use the cross validation equal to 10 or higher, it will take a lot of time. So we need it. And we will do the same to the best model equal to tune.out with best model, and we use the summary of the best model. So here we go, and here we have the cost function equal to 10 and the degree equal to 1. This is the best function for polynomial. So if you put the cost function equal to 10 and 0 is equal to 1, it will give you the total accuracy is 61.66. So the total accuracy with this best model, we will get 61. This is on the training data, and we use 4-fold cross validation on training dataset. So on the training dataset we can get 61. If you run this one predicted on the test data, you use the same. This is best mode, we use it with the test for polynomial. So, and then we use this is table between polynomial predicted value and the actual value. So we'll have this is 29 plus 36. This is the total predicted value, the corrected value. Okay, and then we have the last one, Radial Kernel, the last one, and we have first set your seed, so we have the same value, and then we have to fit our model on the same on the training data. So this is SVM super vector machine. This is independent variable, tell the all for all my data, and we have the kernel in here equal to radial. We have another function is called the gamma, and the cost equal to 1. So we should find we tune our parameter to find the best value of C and the best value for the gamma. If you don't know what I'm talking about, just back to the previous video, we discussed in more detail about the Radial Kernel. So the same tune parameter, this is SVM, this is independent variable, data equal to train, the kernel is radial in here, and the range in here we try to find the best value of C and the best value of gamma, the best value of C, and we have this function, this is range equal to list, cost equal to C, is we need to find the best value of C and the best value of gamma, and the cross validation equal to 4, is it just to make our cross validation not complicated. Have to wait for the model to finish. And we'll do the same, we'll find the best model, we summary the best model and to check our data. We're waiting the model to stop. If you use the cross validation very high, so the model will be very slow. Cross validation I keep it 4, and then run our model. It's gonna check our value. So the cost C equal to 5, and where's the gamma ray? Gamma ray equal to 0.5. This one the best to fit our model. So this is the best model, tune dot the best model, and if you need to find the gamma ray, you should use the tune.r, the best parameters. You have to put the gamma to find the best gamma. And same, we do the predicted value on the test data and scene data, and then we use the confusion matrix to check our predicted value on the confusion on the test data. So this is all you need to know about the support vector machines, how to run that in R. Thank you for watching, and see you in the next video.